JUnit test suites and the Launcher API. Lecture 7. Making test suites. JUnit 5 has all but replaced the @runWith annotation with the @extendWith annotation and its attendant extension model. But for backward compatibility and for seamless integration with the current crop of integrated development environments, however, the JUnit 4 test suite model has been retained in its old form, with the @runWith JUnit platform.class semantics being an acceptable way to run JUnit 5 tests, but at the expense of not having access to cutting-edge JUnit 5 features. For most testing scenarios, this is sufficient, and I'm going to make a 15-second pause to enable you to write down @runWith JUnit platform.class. Let us go. However, the Launcher API provides a totally JUnit 5 way of doing things, albeit more verbosely and programmatically, not declaratively. Let us look at test suite composing by using the @runWith annotation in the next slide. You may wish to refresh the @tag annotation before delving into the next slide, as it plays a prominent role in filtering unit tests to be run in a test suite. This annotation is found in Lecture 4. These are the relevant annotations to create and to configure a test suite, and I'm going to make a 15-second pause after each one to allow you to write it out. @runWith, its only acceptable runners class is called JUnit platform.class, as we saw before. @select classes. @include class name patterns. @exclude class name patterns. @select packages. @include packages. This is a way to include sub-packages to the annotation @select packages. Next annotation, @exclude packages. This is a way to exclude sub-packages to the annotation @select packages. Next annotation, @include tags. @exclude tags. So the values to these annotations, which are passed into these annotations, can be a single value or an array, except for at run with, of course, which takes just one parameter. Some examples of creating and configuring a test suite follow in the next slide. So I'm going to give you about 1 minute to look through all these 3 examples. So as you can see, you annotate a class which becomes your test suite class. Let us go to the next slide. And there are a couple more examples which I'm going to give you about 45 seconds to study. As you can see, the flexibility of test suites is quite high, and you should be able to get just the right mix of tests you need. And you can filter tests by tagging them as well. So basically these annotations are to help you select and filter test classes, unit tests, etc. And whatever comprises a test suite can be run together by the JUnit runtime. So let us continue to the next slide. Launcher API. The latest and greatest way to launch and to run unit tests is via the new Launcher API. This API is great for integrators looking to integrate JUnit and an integrated development environment, such as Eclipse, MyEclipse, IntelliJ IDEA, etc. However, you can also write your test suites by using this API, albeit in a programmatic way. The following slides delve deeper into this API, and then we conclude by showing you the test engine API. Yes, you can write your own test engine with JUnit. Before you can run tests, you have to find tests in your project or elsewhere. It was the case with the test suites, and it is the case with the Launcher API. And of course, I urge you to undertake the lab which follows this lecture, because it is there where you're going to learn how to use the test suites and the Launcher API by hand. Test discovery, therefore, is what must take place initially before you further utilize the Launcher API. The first class you will use is called Launcher Discovery Request, and it is created by using the class Launcher Discovery Request Builder. And what I'm going to do, I'm going to give you 30 seconds to write out these 2 class names. Just as you use annotations when creating test suites, for example, add select package and add select class annotations. You use methods such as select package and select class to configure your test discovery class launcher discovery request. Just as you include or exclude classes, tags, and class patterns, you do the same when configuring the launcher discovery request class. You select packages and classes by using the selectors method. You filter packages and classes by using the filters method. Let us look at a code example to follow in the next slide. Be sure you work through the lab as well. First, import some static methods. And I'm going to give you about 20 seconds per import. So let us go. Import static org.junit.platform.engine.discovery.classNameFilter that include class name patterns. Let us go to the next import. Import static org.junit.platform.engine.discovery.discoverySelectors.selectClass. Next, import static org.junit.platform.engine.discovery.discoverySelectors.selectPackage. Let us go to next slide. Then, write the fluid syntax of our configuration for test discovery. And I'm going to give you about a minute to study this line of code. Now what I would like you to do, I would like you to write out names of 3 classes. They are launcher, launcher factory, and test plan. And I'm going to give you 30 seconds to do it. So again, launcher, launcher factory, test plan. Now we have a test plan that can be run by the JUnit runtime. Pretty neat. The following are the classes and interfaces from the org.junit.platform.engine.discovery package. And I hate to do this to you, but I'm going to ask you to write them out, and I'm going to give you 15 seconds for each one of those. So the first one is class path resource selector. Class path root selector. Class selector. Directory selector. Discovery selectors. Next slide. File selector. Method selector. Module selector. Package selector. Unique ID selector. URI selector. Class name filter. Package name filter. You can do flexible selection and filtration as the result of this API. The test plan you obtain from this API can contain more than one test engine. It represents test engines, test containers, which are test classes, and tests, which are unit test methods, and it represents them hierarchically. You can traverse this tree and get to any node you need to get to. You can register launcher discovery listeners to get notified about various events that take place during the process of test discovery, which happens via launcher discovery request builder. So you can register launcher discovery listeners via launcher discovery request builder. And I'm going to ask you to write out launcher discovery listener. And I'm going to give you 15 seconds to do it. All right. This builder registers a default listener if you do not register any other listeners. You can specify what class functions as the default listener by using the JUnit.platform.discovery.listener.default property in the JUnit-platform.properties file, or as a Java virtual machine property at runtime. And so I'm going to give you 15 seconds to write out JUnit.platform.discovery.listener.default. This parameter must be provided as a fully qualified class name. If this parameter is missing and you encounter some error during test discovery will not proceed further. After you discovered your tests, you can either display them in your tool, or you can reuse the discovered tests to immediately run them if you're writing a test suite programmatically. To follow events during test execution, you can register one or more instances of test execution listener implementations. And I'm going to make a 15-second pause for you to write out test execution listener. Code to discover and then to immediately run unit tests follows in the next slide. So what I'm going to do, I'm going to give you about 1 minute to study this code. Also, I'm going to ask you to write out the following class names: summary generating listener and test execution summary. So summary generating listener and test execution summary. And I'm going to make a 30-second pause for you to write them out. This code sample is made in a bulleted fashion to make following it easier, but you still must take part in the lab which follows this lecture. JUnit as of March 2020 provides 2 test engine implementations: JUnit-Jupyter-Engine, the latest and greatest, and JUnit-Vintage-Engine runs JUnit 4 tests on JUnit 5 runtime. And I'm going to give you about 30 seconds to write out JUnit-Jupyter-Engine and JUnit-Vintage-Engine. Engine registration is supported via Java's java.util.service loader mechanism. And I'm going to give you about 15 seconds to write out java.util.service loader. For example, JUnit-Jupyter-engine is registered in the org.junit.platform.engine.testengine file in the metainf/services folder in the JUnit-Jupyter-engine jar. And I'm going to give you about 15 seconds to write out org.junit.platform.engine.testengine blank file. Alright, let us go to the next slide. Hierarchical test engine is a convenient abstract implementation of the test engine interface. And I'm going to ask you to write out these two names, one for a class, another for the interface. So hierarchical test engine and test engine. And I'm going to give you about 20-second pause to do so. So hierarchical test engine requires the implementer to only implement test discovery logic, which we went over previously. It is used already by JUnit-Jupyter-engine, and you can use it as well. It implements execution of test descriptors, implementing the node interface. Recall, test discovery returns a hierarchy of nodes, and it supports parallel test execution out of the box, so you don't have to write your own such functionality. And I'm gonna give you about 20 seconds to write out test descriptor and node. Let us go to next slide. You can also implement your own custom test execution listeners, and you can register them via the same java.util.service loader mechanism as a custom test engine. Currently, JUnit supports the following test execution listeners out of the box. And please write them out. I'm going to give you about 45 seconds of time. They are legacy XML report generating listener, login listener, summary generating listener. The last one you already wrote before, but please write it out again. So let us start. Let us continue. If you would like to do more than basic launcher configuration, you can supply your own code for the launcher config class, such as follows. But before you go on, please, I'm going to give you 10 seconds to write out launcher config. Please do so now. Alright, I'm going to give you a minute to study the code snippet on this slide, and then we're going to go to the next slide. Let us go to the next slide. And I'm going to give you about 30 seconds to finish studying the code snippet. Please make sure you understand the Launcher API completely, and make sure you do take the lab. It's very important. You can use this API to write your own test engine. And of course, the best way to do so is to write the hierarchical test engine implementation to finish writing it. Once your test engine is ready and running, you can use the engine test kit class to test that it is working as you intended it to work. Now I'm going to give you 10 seconds to write out engine test kit. So the engine test kit class allows you to do some nice things, such as you can verify your test engine statistics, and you can test that your test engine emits certain events and in a certain order. So the engine test kit class is a very handy test class for your custom test engine implementation. Congratulations! You have completed Lecture 7 dealing with JUnit's test suites and the Launcher API. You now know how to put together JUnit's test suites by using JUnit for test suite concept in order to test parts of the overall unit tests available. And you also know how to write your own launchers to either programmatically create test suites in JUnit 5 or to integrate JUnit 5 with your favorite integrated development environment, code editor, or even the console. And then don't forget to test your test engine, a must. Thank you for your attention in this course. The amount of utility you have received has depended entirely on how well you not only went through the lectures, but took the quizzes and participated in the labs. Good luck.